The goal of this video is to explain a very simple computer architecture that demonstrates all the crucial ideas behind computer operation without being any more complicated than it need to be, and also explain computer encoding because it's widely used in network modules, in operating system, in data transferring, and everywhere else really. So the main computer component is the processor, which usually has a built-in clock timer. In other words, program counter, which is the most crucial component of CPU. Timer is a set of smaller components, including resistor, transistor, capacitor, that literally sits and wait until anything happens in electronic circuit. Then we have a memory address register, instruction register, control unit that orchestrates everything in CPU, and accumulator, which is part of component that holds sufficient arithmetic logic and logic units such as 2's complement I was talking about in recent video, so that you can begin use addition or subtraction within the hardware logic. And so here is a example. We have also other arithmetics such as sign binary, 1's complement, 2's complement, and it's basically a mathematical pattern just to make the math work out. For example, in this example, if 2's complement is working best with negative and positive numbers because of its pattern, and I'll give you an example. If you want to addition -3 plus 3, you put 1 plus 1 is 0, and 1 moves to the left. Then you put 1 plus 1 is 0, 1 to the left, then 1 plus 1 is 0, 1 to the left, and 1 plus 1 is 0, and 4 zeros is 0, so -3 plus 3 is 0, and such. So this sort of mathematical arithmetic works really great with the hardware logic. It works great with the negative numbers, as I mentioned, and so is a part of accumulator components in the CPU that I am explaining right now. And accumulator stores electrical signals into device called memory address register, so that you can begin to build a little bit more complex programs. For example, a hard drive is also storing electrical. In hard drive you also store electrical signals in particular parts of the hard drive to later obtain or delete. Memory, in other words, electrical signals in a chip, doesn't last forever as well in the hard. For example, it started to decay after 10 years of not using it. So overall, computers use various physics forces such as electrical, electromagnetic, ultrasonic, thermal, kinetic, and other, depending on the device itself. In general, electrical signals is equivalent to binary 0 or 1, so to say true or false, or on or off, but electricity as a whole is not that simple because it's sort of the way with variety of properties. So it can be square, sine of triangle, It can be CRDC, can be high frequency or low frequency, so that in later videos you'll find me using multimeter or oscilloscope to measure various properties. So moving back to computer architecture, nowadays computer are built in 32-bit system, which is older version of the architecture, but are still widely used in smartphones due to its amazing computational performance and low power efficiency balance. So although it's worth noting that modern laptops have transitioned to 64-bit, 86-bit architectures years ago, which was an important improvement in computer science. Talking about C programming language, you quite often can find yourself counting zeros and ones in an 8-bit or 16-bit binary convention system, and in many cases controlling electrical or electromagnetic signal itself, of course, depending on what you're trying to achieve. For example, if you need to use a little bit more complex computation in C programming language, you have to reserve some space in random access memory and then release the space after computation is done. This process is called garbage collection, and that's where the encoding comes into the play, such as ASCII. And ASCII encoding is American Standard Code for Information Interchange. This is the chart that I'm on right now. It has a lot of relationship between decimal keyboard symbols, hexadecimal, which is used quite often in colors, and binary, of course. So so it's used on everyday basis, and it's subset of UTF-8 encoding, which is most common and a simple fixed width representation, as well as UTF-16, which is used in other operating systems. I will quickly explain now on how you can convert 8-bit binary to other units and how it's being represented, so you can begin to understand the relationship between hardware and software better. So here is a binary representation chart. Usually looks like that, 8-bit binary, and as you can see, representation is pretty much simple. 1 representing 1, 1 representing 2 is 3, 1 representing 4 is 7, 0 representing 8 is 0, still 7, and so on. So sort of maximum what you can do in 256 representation is a maximum value, but you can also use reminder. Reminder is a sort of modulus counting system, if I can call it like that, and basically you can have even higher number decimal, for example, of 999, and what you actually need to do is just divide it by 2 and read the modulus, the remainder. In this case, we have number 156, and if you divide it by 2, is gonna be 78 reminder 0. If you divide 78 by 2, reminder is gonna be 0, and decimal becomes 39. And it goes down to the bottom, and binary inverts from the top to the bottom in this example. So 156 in decimal will be representation of 00111 001 in binary. This is the way you can count it easily without any program, but with ASCII representation, there is no really good technique to convert it straight away. So you're going to make a Vim plugin that converts ASCII to binary just by typing in a letter or symbol or the decimal in it. So in many cases 256 are sufficient, especially for tasks like representing colors in computer graphics, where 256 values per color channel can provide millions of different colors, or indexing elements in array. Also, I will try not to repeat anyone else online, but rather move to significant pieces of programming and electric engineering that I'm most interested in, when explaining as much as possible for you to follow on what I'm doing. So I leave some interested links down below the video for you as a reference, just in case you are interested to know more about encodings itself. Otherwise, I will be happy to answer your questions in comment section. So the next video going to be about logic gates, which is also very important stuff in computer science. So stay tuned.